Hi, today we're going to go over lesson 6 from Unit 1, and it's about stuff that we've covered probably in our previous lesson and even in Algebra 1 and Pre-Algebra. So I'm going to go through this pretty quickly. So the first type of an equation is slope-intercept form, and that's what we have here. So please go ahead and get your pencil out or pen, and we're going to write down this equation, y equals mx plus b. Now, hopefully you're familiar with this. The slope is the m. Where's the slope? It's always in front of the x. Now for your second form, we have point slope form. So go ahead and write this equation down. Y minus y sub 1 equals m times x minus x1. Where is the slope? Well, it's just like on the prior one. It's in front of x, and I probably should have wrote that. Not sure what's happening to my computer. In front of x. Okay, hopefully you can read that. Now the last form is called the standard form. Now, if you notice, on the first two forms, the x and the y here, they're on opposite sides. And on the second equation here, we have the x and y's on opposite sides. But for standard form, the x's and y's are on the same side. So this is a huge difference. It's not as easy to work with because when you look at this equation, if you notice, there's not an m. The slope is not shown immediately. So you would have to work with it and kind of convert it to a different form. Okay, so I'll tell you what this is if you can't read it. Moving on, two lines can be parallel. Now, whenever you draw, especially in geometry, you don't have to be perfect. So when I drew these two lines here, if you notice, they don't look exactly parallel. But these little markings here in the middle, this marking tells whoever looks at the picture or the diagram that they're parallel. So make sure that this is the marking that you're using whenever you're drawing lines that are parallel. Now, do not be confused with like this symbol. We've used this symbol. This symbol would not be appropriate because this means congruent, and lines can't be congruent since they go forever. So when we did midpoints, if you remember, we said like the left side and the right side are equal. So don't get this symbol confused with the parallel symbol. Anyway, parallel lines have the same slope. So go ahead, write that down. Parallel lines have the same slope and they have no points in common. Now, when they're perpendicular, again, go ahead and draw the diagram. The picture doesn't have to be perfect, but you do have to put the 90-degree angle because without it, whoever looks at your diagram can't assume it's 90 degrees. They do have one point in common, that's where they cross, and the slopes are opposite reciprocal. So I have two little examples here. So if I give you a number and I said a half, the opposite means the opposite sign. So it goes from positive to negative. And then reciprocal means you flip it. So it goes from 1/2 to 2/1. So I made up another one. I said, okay, you have -3/5. I want to go from negative to positive because it's always the opposite sign. And then I want to flip it so that it's 5/3. Now, when they're intersecting, notice there's no markings here. It doesn't show the perpendicular, it doesn't show the parallel. There's just two lines that cross. And so these are neither parallel or perpendicular. Now, there's geometry shorthand here. This little symbol means parallel. So when you're writing, you can use this symbol instead of writing the word parallel. And this upside down capital T you can use instead of writing out the word perpendicular because it's a really long word. So you technically, see how I wrote this last line? You could just write that and everyone knows what that means. Neither parallel or perpendicular. Now the last scenario is with the lines are graphed and you graph the second one and the lines are on top of each other because the lines are the same thing. You graph the same equation twice. So if that happens, they obviously have the same slope because they're the same equation, and they have every single point in common because one is literally graphed on top of the other. Okay, so that hopefully was review. And this next part should be 2. If you are given 2 points, you can find the slope by counting. We did this last class. Or you can use the slope equation. And it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We talked about how this is rise over run. And shorthand for the word change is a triangle. So this could be the change in y over the change in x. All these are ways that you've talked about how to find slope. Now, we know the slope. What's the equation? Okay, so let's look at the picture here. And, it tells you the slope, but let's practice doing this. Now, the way that I'd like to do it is I start the lowest point and I rise up. And I went up 1, 2, 3, and I'm writing backwards 2. So since I ran backwards, it's negative. So it's a negative 3 over 2, and that's what it says. So we can pick any 3 of the equations to use for a line, but which one's easier than the rest? Well, if they give you a point and they give you the slope, I would use that. Now, if you notice, you don't have the intercept. It's not shown. The intercept is where it crosses this y-axis and it's not shown. So definitely for this problem, it is point slope form. Okay, so let's try this. Now I already know my slope is a negative 3 over 2. Now if I'm using point slope form, I can use either of these coordinates. They're both going to work. So I'm just going to pick 1, 1. I'm just going to pick the first one. So I'm going to call this x1, y1. And if you refer back to the top of your notes, we said the formula is not that, Mrs. Provost, is y minus y1 equals m times x minus x1. So the way you do this is you drop down the y. You look up here and you say, oh, y1 is 1. By slope, I already know. I counted it out as a negative 3 over 2. Drop down my x, and x1, look up here, is 1. Okay, so what if I want to change this to slope intercept? Okay, so I'm going to take this equation, and again, we practiced this last class. We're going to distribute the slope. Okay, so this is a negative 3 over 2x. Now be careful, a negative times a negative is a positive. Now we're not finished. For slope intercept, remember it's y equals mx plus b. So I need to solve for y, which means I have to move the negative 1. So the opposite of negative 1 is positive 1. Okay, so remember, your slope always has to remain a fraction because we want to see the rise and run. Now, this right here, you may have trouble with. We can kind of take it to a decimal if it helps you. 3 over 2 is 1.5. So what's 1.5 and plus 1? Well, that's 2.5. I mean, that's fine. I mean, that is the correct equation. Make sure this remains a fraction, though. Slope is a fraction. Slope is a fraction. Okay. So we're just going to practice a bunch of these. All right, let's find the slope. And we have to do that by using the slope formula. So I'm going to label this as x1, y1, x2, y2, and I'm going to subtract. So 0 minus 2 and 3 minus 0, which is a negative 2/3. Now this is up to you which point you want to use. I'm always just going to pick the first one because, why not? I like to always write my equation out. It really helps you learn your equations if you write it out every time. y minus, now look up here, y sub 2 is 2. Your slope, you already found it out, is a negative 2/3. X minus, and x sub 1 is 0. All right, so let's fill in some of these blanks. My slope is a negative 2/3. Now, PS equation means point slope equation. This is point slope equation. Now, things about this. This equation's fine, but do you guys remember if it's a 0, you really don't have to put it? It's not all the way simplified. So technically, I could just write a negative 2/3 x. If you wanted to write it the other way, I would go ahead and count that. Okay, so the next one's going to be the same. We're going to first find the slope. Let's label x1, y1, x2, y2. I'm going to write my equation out. So negative 2 minus 3, negative 2 minus 1. When I subtract on my numerator, I get negative 5. And across the bottom, my denominator, I get negative 3. But a negative over a negative is a positive. All right, so we're going to want the point slope equation again. So pick a point. I'm going to pick the first one because why not? I'm going to write my equation. So y minus 3 equals my slope, which is 5/3, and x minus 1. Now, I'm going through this pretty fast. You have, of course, the ability to pause the video if you need to. But right now we're just plugging in information. And we did this last class, so this should hopefully be pretty easy for you. Because we're going to take what we've been doing and kick it up a notch now. Now I can slow down just a little bit. So now we're going to first find the slope. We're going to find the equation. And then what we have to do is determine if the lines are parallel, perpendicular, and all of that. Okay, so one step at a time, I'll walk you through it. So the first step is to find the slope. Okay, so let's subtract. Negative 1 minus 7, and then 6 minus 7. So this is negative 8 over negative 1, which is 8, or 8 over 1. They're the same thing, obviously. Okay, so what I need to do is, I'm not really sure why this is here. What we're going to do is we're going to look at this equation and pull out the slope. Okay, we're going to pull out the slope of this equation. We're going to compare it. And so what I'm going to write instead here is I want to say this is your given slope. And this is, what do I want to say? I'm just going to write slope again. We're going to just write slope for both. Let's find the slope of this line. So y minus y1 equals m, x minus x1. All right, you probably already knew this, but look, in front of x is the m. So this is your slope. So we're comparing them. Okay, so we're comparing this slope to this slope. Are they the same number? No, so we know they're not parallel. Are they opposite reciprocals? Well, here's 8, and the opposite of positive 8 is negative 8. And if you take the 8 over 1 or the 8 and you flip it, you get 1 over 8. That seems like, yes, it is the same. So this is perpendicular. You know what? I just figured out why they have equation here. We'll do it for the next one. I got it now. For that one, we'll just write slope. I won't make you go back. Okay, next one. Let's find the slope. Okay, well, look, right there's the slope. and they give you this. So my given slope is 2, and I need to write an equation. So I'm going to go and let's see, if I have a point and I have a slope, I'm going to use point slope form, which is y minus y1 equals m, x minus x sub 1. All right, so let's label this. Let's plug it in. So y minus 14 equals 2, and x minus, oh my, x minus 10. All right, so the equation, what they're asking you is to write something like that. Now, let's compare it to this one. Are the slopes the same? Are they parallel? Are they opposite reciprocals perpendicular? Do they really have nothing in common? So they're just intersecting lines, or is it the same equation? Okay, so when I look at them, I see they're both a 2, which tells me, hey, they're going to be parallel, which means they can't be perpendicular and they can't be intersecting. Now, to determine if they're the same, here's the thing though. You could plug any point into this. We have to change the form to see if they're the same. Okay, and I know you don't want to, and I'm sorry. So what you have to do though is you have to put it into slope intercept. Okay, so it's just a couple little steps. We're going to distribute. So 2x minus 20 and add 14. So y equals 2x minus 6. All right, so let's see if this is the same equation. Y minus 0 equals, and distribute, 2x, and anything times 0 is 0. Now when I look at this one though, are these two equations the exact same? No, of course not. This one has an intercept of -6, this one has an intercept of 0. So the answer has to be, they're parallel. All right, and this one, that's the equation. All right, so on this one, you have to look at the picture. Now, you can't assume they're perpendicular. I mean, I could probably assume they're not parallel. I mean, but, and I can tell you that they're not the same line. But the slopes have to be opposite reciprocals. So we have to figure out the slopes. And when they give you a graph, you can count the slope out. I mean, that's allowed. So let's just count the slope out and compare them. Okay, so I'm going to go up and over. Let's count this out. 1, 2, 3. 1, 2, 3, 4, 5, 6. So my first one, which is called line 2, is 3 over 6, which is 1/2, and it is positive. Now the line that goes down is line 1, and I know that because of this. And I'll change colors. I'm going to go up and over. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Now, guys, I went backwards, so this is negative. So it's a -8 over 4, which reduces to -2 over 1. So we're comparing these two, and that they are opposite reciprocals, right? You flip it, it becomes 2 over 1. One's positive, one's negative. So that definitely means it is perpendicular. Why? Because they are opposite reciprocals. Okay. So again, on this one, we're wanting to know, are they parallel, perpendicular, intersecting, or the same line? Okay, so first, let's find the slope. Okay, so slope is 9 minus 7, and then 3 minus 3. So that's 2 over 0. Uh-oh, what's that mean? If there's nothing, can you have 2 of something? And obviously you can't. So this is undefined, which means it goes straight up and down. It is vertical. So what is this line? Well, let me remind you. So go to the x-axis, go over to 3, put a dot, and it has to go through that dot only one time, which happens to also be vertical undefined. Okay, so what's happening? Let's go make it a different color again. If you actually look, if I graph these two, if I go over to 3 and up 7, let's say that's 7, and then I go over 3 and I go up 9, do you guys see how this is the same line? Oh, I kind of missed. I'm graphing the red right on top of the blue. It's the same equation. Okay, so the slope is undefined. It's 3 equals 0, and this is the same line. What happened? Same line. All right, we're almost finished. What is the slope of a segment AB that passes through 0, 0, and 4, negative 4? Okay, so we need to first find the slope. And again, you could count this out by hand. They give you the coordinates. You can do whatever you like. I'm just going to do this. So negative 4 minus 0 and 4 minus 0. So I get negative 4 over 4, which is negative 1. Or 1, 2, 3, 4, 1, 2, 3, 4. I was just looking because it doesn't look exactly right, but I think it is. It's fine. Okay, so what is the equation? What is this? Okay, so it just says find the equation. We can do that. Let's do point slope. And again, I want to pick the first one. Y minus 0 equals negative 1, x minus 0. Guys, there's a lot of zeros in this problem. And so, not sure what's happening. My computer's possessed. Okay, so really, I could get rid of that 0 and just say y equals negative 1x. Because if I distribute, negative 1 times x is negative 1x, and negative 1 times 0 is 0. Okay, so now it says to graph this onto the same graph and determine if it's parallel, perpendicular, or neither. Okay, so we again did this last class. We're going to have to pull out information. Now, so you're going to take the y value, you're going to pull this out and change it to the opposite. You're going to pull this y value out and change it to the opposite. So my coordinate is negative 2, negative 2, and this is my slope. So my slope is negative 1 over 1. So we're almost finished. So negative 2, negative 2. And so now my slope is negative 1. So up 1, back 1, up 1, back 1, up 1, back 1. All right, let me see if I can halfway draw that in. All right, now what you can see though is they have the same slope. So let's get the highlighter. Here my slope is negative 1. Here my slope is negative 1. These lines are not intersecting, so they are definitely parallel. So I'm going to put my parallel symbol on it. So they are parallel. All right, that is it. Come to tutorial or ask your teacher if you have any questions.